Hi, okay, this is our Integrative Physiology midterm video. I'm with my mom here, and I'm going to be explaining the figure 8 of positive feedback and insulin resistance. Okay, so to begin, I'm going to draw, this is a figure 8 loop, and it's going to be showing how our body regulates insulin and our blood glucose levels. So to begin, we have a stimulus. So our stimulus is going to trigger the hypothalamus of our brain. So hypothalamus would be here. Just write hypo. But the hypothalamus is our chief center, so it's going to be making the decision of what it's going to signal and what hormones it would release. So it is going to then signal our effector organ, which would be our pancreas in this situation. So we have our effector, and this is our pancreas. And so our pancreas is going to signal our insulin. So we have our insulin here, and basically, I'm sure you know what insulin is, but it regulates the amount of glucose that is present in our blood. And our insulin is going to bind to a type of receptor. It is called a tyrosine kinase receptor right here. So we'll just put TR, and normally this insulin would bind to our tyrosine kinase receptor, and it would take glucose into our cells. And so say we just finished eating a meal and our blood glucose bumps up a little bit to 120. So say our normal range is 70 to 100. It would then bring our glucose intercellular, and hopefully after one cycle here, it would bring it back down to a normal range of 70 to 100. And then, so vice versa. So this would be our action of lowering glucose. And then we're going to have a vice versa where we want to raise our glucose. So we would have a drop in glucose, and same thing we'd have in the hypothalamus, which would trigger then our pancreas to release glucagon, and glucagon binds to our, it's called a G protein receptor, and that would then get us back to our set point. So this would be raising glucose in the situation, and this would be lowering. So the main problem that we run into with this is people that are metabolically inflexible are going to have insanely high glucose numbers at resting value. So say say you're on a consistently bad diet, and your blood glucose when you're just in a post-absorptive state, so this is the state where you're like 4 to 8 hours after eating a meal, is consistently like 180. So this is going to cause your body more time and energy to get around the cycle, because when you get back to here, you're not going to be able to just be right in your set state. You have to go around again and again and again. So your cycle, if you're having too much insulin, is going to be something like this instead of the normal figure 8 model, if that makes sense. So the problem we run into then is we're going to have too much insulin in the blood. So this is going to end up decreasing the, it's going to decrease the insulin receptor's ability to respond to insulin properly. So then we're not going to be able to get our blood glucose down to a normal level, if that makes sense.
Yes.
Do you have any questions?
Hold on. So that whole cycle and the inability for that cycle to operate efficiently, that's what develops the insulin resistance to where you're constantly at a high number at a resting state.
Yeah, that's correct. So yeah, the receptors just end up, when you have so much insulin in the blood, your receptors aren't going to respond to the signal that they want to bind naturally. So then the insulin's going to have to stay in the blood, and we're not going to be able to change our glucose number to one that's in a normal range. And then we can have problems that we're going to be in a hypertensive state then, and we're going to have additional problems that are related then. And we're going to be more likely for like coronary artery disease or having a stroke down the future.
Right.
And
So Is
Yeah.
insulin resistance just another way of stating that you have diabetes?
In a way, yes.
Okay.
Yeah. But I feel like that's about it. And then, yeah, the problem we tend to run into then is, um, so yeah, I think that's probably about all. That's all I'll touch into. But if
Okay.
yeah, does that make sense? Is there
Yes, it does. Thank you
any
so much for
specific
your.
questions about the cycle you would have?
Um, I was a little unclear. You know, at the very bottom of the cycle. What's that word?
Sure. Which part? Right
Not
here.
the very bottom. No, go left. What's that word?
Hypothalamus.
Oh, okay. That's what you
Yeah.
just.
So yeah, I was just kind of touching on how if we wanted to raise our blood glucose, yeah, I know this picture is not the best, but we'd have a drop
That's
in
okay.
glucose. It's kind of the same thing. Our hypothalamus would trigger our effector organ, which is our pancreas, to send glucagon, and then we would also have so our glucagon would bind to a G coupled receptor in our adipose muscle and liver to raise our sugars in this